Dr. Lokesh Gupta. Welcome to my YouTube channel. Today we talk about how to calculate the chi-square test manually. What is chi-square? Chi-square is a statistic is commonly used for testing relationship between categorical variable. So when is the important thing? Chi-square generally calculate on categorical variable, and the purpose of analysis is to testing the relationship between the categorical variable. Okay, null hypothesis is that chi-square, in case no relationship exists on the categorical variable in the population, they are independent. So we are assuming both variable are independent, and we consider there is no relationship in between these two categorical variables. Chi-square test represent a useful method of comparing experimentally obtained result with those to be expected theoretical on some hypothesis. So very important thing about the chi-square test is कि we just compare the experimentally obtained result as well as the our expected or theoretically explained and the some frame of hypothesis have our expectation. So most of the time we use the equal probability hypothesis to assess the obtained versus the expected frequency. Equation for chi-square test. Whenever we talk about the equation and the formula for the chi-square test, this is the very simple and the universal equation you can use for any type of data. This is the basic equation of chi-square. Frequency Fe means expected frequency and the minus observed frequency. So now the important thing, we have to calculate the difference between our expected frequency and the observed frequency, and square of the difference and divide by the expected frequency, and the total of this is the value of chi-square. So this is the basic and universal formula. We can use this formula for one group, two group, or sometime maybe 2 into 2 contingency table, or more than 2 into 2 contingency table. So this is the basic and universal formula or equation for chi-square. There are certain assumptions in chi-square test. First one is the random sampling of data is assumed to in the chi-square test. So we need random sample. And second is the a sample with sufficient large size is assumed. So we are considering that we have a large data site, and on the basis of these things we calculate the chi-square. On a sample of large size, then chi-square test will be yield inaccurate inferences. If we take a small sample, so there is a chance that we are not able to take a right inferences. So that's why suggestion that we take large sample. A researcher, by using the chi-square test on small sample, might end up or committing type 2 error. So type 2 error, I think all of you are aware about the type 1 and type 2 error. Type 2 error, we accept the null hypothesis, but we have to reject. So the next point is, in the chi-square test, the observation are always assumed to be independent of each other. So it's totally independent. And the third point, the chi-square test observation must have same fundamental distribution. So these are the basic assumptions of chi-square test. Uses. First important use, chi-square test is a test of independence. Second is the test of goodness of fit, because through this we just compare the theoretical distribution and the our obtained distribution. So we just compare our expected versus obtained. So we test the goodness of fit. And the third one is the chi-square test is a test of homogeneity. We test our homogeneity in the test, is it homogeneous or not. Goodness of fit. So now we take an example of goodness of fit. When an analyst attempts to fit a statistical model to observe data, he or she may wonder how well the model actually reflects the data, and how close are observed value to those which would be expected under the fitted model. and one statistical test that address the issue of chi-square of goodness of fit. So our major purpose to this is the very good example. It's one taken from the Garrett book. The example mentioned in Garrett book is 254 to 255. So this is the example. Suppose in this example testing a divergence of observed result from the expected on the hypothesis of equal probability or null hypothesis. So we want to test our null hypothesis or we are assuming equal probability. So now we read the statement. As per this question statement, 48 subjects were asked to express their attitude towards a preposition and should the United States joins the Organization of Nations for the Control of Autonomic Power by making F favorable. So response is in three category: favorable, indifferent, or unfavorable. So now we find the value in favorable. There are out of 48, there are 24 person report favorable, 12 persons report it's indifferent, and 12% report it's unfavorable. So as per our observed frequency, this is the observed frequency 24, 12 and 12. But our expected frequency, again it's a simple thing. Our expected frequency is the equal probability. We follow the equal probability. So now we just total it. So 48 divided by 3, because there are three type of opinion, maybe three options is there. So now we divide by 3. So now 16 is the our expected frequency. So now we check the difference between observed and expected. So basic formula of chi-square is observed minus expected and square of the difference and divide by expected frequency. So difference between the observed and expected is 8 for favorable. Difference between observed and expected in indifferent is 4, and again the 4 for unfavorable. So this is the difference, and the square of this difference, 8 multiplied by 8 64, 4 multiplied by 4 16, and 16. So expected frequency and observed frequency differences and the square of these differences and divide by the our expected frequency. So expected frequency is the 16. So 64 divided by 16, the value is 4, and the 16 divided by 16 value is 5 1 and again 1. So now there are total of these things, sigma of all these three values, so means 4 plus 1 plus 1. So now 6 is our chi-square value, and the degree of freedom is 2, and the level of significance is 0.05 level. So now we have to go and check the table E, is it significant or not. So on the basis of our result, now we find it's significant because our value is chi-square value is 6, and the degree of freedom, obviously there are three opinions, so n minus 1, so degree of freedom is 2. Now we go and check the table and we find, if we see this one, so our expected, and we can calculate in this manner as well, r minus c column and row. So there are three rows and the two columns. So again it's 2 our degree of freedom, so we just calculate, and on the basis of this table we can see that our result is wait a minute, yeah, whenever we see the table number E in Garrett book, so we find degree of freedom is 2 and the chi-square value is 6, and we find actually 5.9991 mentioned, so it's significant at 0.05 level, and it means it should be, we repeated this experiment only once the 20 trials, once in 20 trials means 0.05 level, okay, occurs when the null hypothesis, it means there are 95% confidence interval. One result will be marked significant at the 0.05 level. So this is the p-value and the difference of chi-square. So for these things you can see, refer the Garrett book and page number 255 in Garrett. So if we see this Garrett book, we find this type of table. So our degree of freedom is 2, and level of significance at 0.05 level. So value, our tabled value is 5.9991, but our obtained value is 6. So now we can say it's significant at 0.05 level, but at 0.01 level it's 9.2. So if you obtain more than 9.20, so we have significant result at 0.05. But now in this case our result is significant at 0.05 level. So this is the example. I hope you enjoy this video, and thank you so much. These are the contact details. You can contact me. You can like this video. You can share this video. If you have any doubt, you can comment on this video. Thank you so much for watching this video.